Okay, so morning, Master Mason. No, morning, Briff. We got Mackie running on intellect there on the computers for the school. So I hope you know this all blows up on him. So in here, I know the last couple days I've been hammering down the uh, EPR paradoxes, and I put up a few Stanford teachers on the Stanford teacher. I use Leonard there on a lot of other material, black holes, things like that. He's kind of my good standard candle. I like the way the classroom works for it. It's got that good explanation from a teacher. Like, stay motivated, do the experiments. But yeah, on the other side of that, it has what they all have, that this is the classroom. And essentially that's what I want to talk about. Well, understanding those paradoxes and why space might be a quantum object. Let me try my best to explain that to you this morning. Firstly, I like doing them in the stone mill, right? Because it's a little easier for people to see, hey, this is the tomb of the unknown Mason. This is the tomb of the unknown soldier. This is your coffin. The Green Mile. The Long March, yeah. So in there, it's a little easier for people to see it. But let's face it, this box right here is the same space, quantum space, as much as it is the EP paradox and EPR paradox. All right, so what those basically two are is there are problem relationships with each other in simultaneous particles, or at least that's the thought experiment. Obviously, a lot more. When you understand calculus, and remember, this is intellect here, back to the computer, some of the stuff we've already used, except for the real differential is something like a phase set. Anybody can count, but it takes somebody a little special to be an accountant, especially amongst fields of magnitude for something like Boeing. Right, it's like I could count numbers, I've done inventory before, but let's assume that there's a little bit of space and time necessary that we have to rely on as a physical object for boot camp or a history on what that is. So they're going to get into a big problem about where did you get your tutelage from. Commonly in the system, and you're right, when you feel where you're going with this, but you're also wrong in the aspect of can you quantify that difference, because your own paradox on this end says, because I know X, Y, and Z, given this paradox, I should know what this Boeing effect is as Jordan Scoville in the stone mill. Are all the calculations there? You're damn straight they are. Are all the reviews and all the systems and same actions necessary going to be happening? Absolutely, that's what happens. They share a common goal with each other, and in the reality of it, there's a worker in there. There's a worker over here, or a thermaler here in this company, and a thermaler over there at that company. With the calculus ranges, I should be able to tell you, they're running the same stock. A 3-foot section of rock burns like this. They're very small increments of space. These are the torch, the stoichiometric ratio, in general relativity, plus minus the algorithm of what the 0-1 frame is that defines the start and the end, the limits, the omega points of what this calculation is. And it's not necessary to use black hole calc. It's not even necessary to use it on the high end. That's the thing. It's like, oh, well, that's the difference between, a paper plane build and Boeing. And the truth of the matter is, no, it requires many of those calculations. Remember, Demon on the Gate, still a problem we have to do. We have to entropy the one job that they do, because go look around. Clearly, this is not that perfect. Physics will not agree with you by this standard. Even though there's a lot of good in there, we still have a huge epsilon sphere here, or Epson sphere. Hawking's radiation leaking all over, tachyon radiation, and that's our physics that we rely on that. That's true. We know that because that should be the result for the number that we determine physics to be from this position. And therefore, that other thermal in that other company should have a result of this. When you go to check those things as a manager or safety officer, you can rely on that physics, that this number with your negative numbers will output a negative number on the result, whatever form that may come in, because we're generalizing it again. Space and time are going to switch to the black hole here. Here we're looking at it through perspective, which changes its dilation in relation to respect of what those positions really entail. Now, all thermal positions are the same. There's different topographies. You might be in a different country, which would determine a mass gravity, an epsilon fear around that object to really determine the surface, its position, how close you can get it amongst the quantum object that is the event horizon that leads to omega in general, because you don't need a black hole to die. That'd be the limit. You don't need a black hole to say, well, better turn back around. It can be a lot of things that share the same nature when you're looking at one of those flaming chainsaws across the room coming at you. So that's my notation for today. I'll probably be taking a couple more notes on this one in the stone mill, see if we can piggyback off of that. But that's why the nature of space is quantized. It's a quantum object. Just look out there in space. I can't tell you what's going to go on in there. The size of the object needs to determine that space and limits, because then it's a distance. And if the speed increases, then the distance increases. And I would need to know that, because it's going to turn a relationship into time. If I have any one of those numbers and I can correlate that plus a few irrational values in the calculus for what that object is, it's going to output a graph which will definitely be the determination of what the mass is, but I still need it to hit another object. I still need it to travel through a variation of that space so those two calculuses can graph again, and I will have a better idea of the mass, spin, charge, what it'll look like in physics by comparable numbers. Fire is hot, so it's probably red and made of light, or underneath that relationship to the event horizon, given that surface and mass gravity, that it would still be a fireball underneath there, but it darks it out in this region because of some reaction, oxidation of potassium just left in the environment. That's its triple point. That's what it does. It's just not going to immediately react like it would in a chemical experiment when time or space, what it's next to, rose gold to silver gold to, again, oxidizing potassium, to say that is the element, space and time in this situation, that provides the net force for oxygen, the electron, to share some kind of relationship with each other, if only in that composition, the electron shell, the interference pattern, the scatter aspect of those things in their outer horizons and edges and atmospheres. So, and that's what you do in the stone mill all day. That's usually, and it's burning rock, checking up, down, then that thing switches over, and you're doing a bit of both. You're reacting potassium in solution, but you're also regenerating that potassium or that event by matters of dark energy, reverse engineering a dark energy alien spacecraft. After that's all burnt up, the operation, turn it back into time and space so we can put more blocks back in here, have our resumes squared away, so in case something happens, we can bounce out and do our thing. So that's our note. We'll be getting back on it. Catch you on the next one.